Hello everybody, welcome to this Micronaut versus Quarkus versus Spring Boot performance comparison on JDK 14 in 2020. So for those of you who don't know who I am, my name is Graham Roche and I am the creator of Micronaut. So as you can imagine, this particular comparison is probably going to be biased, but one of the reasons why I wanted to do this comparison was because there's a lot of misleading information out there. In fact, if you do a search for Micronaut versus Quarkus on Google, the first post that appears is this wildly inaccurate performance comparison, which is misleading users into thinking things are what they are when they are not. So I'm going to go through a demo of building an application in each of these frameworks, and we'll have a look at the different performance metrics associated with each one. So first off, let's talk about the test environment first of all. So what I have here as a test machine is my local computer, which happens to be a iMac Pro 2017 model with an 8-core Intel Xeon chip, 32 gigabyte memory. So even though I'm doing a screencast at the same time, I think this machine will cope with that and hopefully give us accurate output numbers. The other important factor to take into account is that I am using Java JDK 14, which has just come out, so that we can see the most accurate picture of where we are today in terms of these numbers. So to begin with, I'm going to start with building a Micronaut application. So I'm going to say Micronaut using the command line. So it's one of the differences between Micronaut and Spring Boot and Quarkus right now is that we do not have as yet a kind of website to create apps with, but we are working on that, so never fear, that will come. But essentially you can do mn create app from the command line, which we do provide, and you can say Micronaut example, that's the name of your example app. And to make this comparison kind of apples for apples, we're going to use Maven and use Maven across all the different build tools. So that will create me a Micronaut application. So let's open that up in an IDE, in this case IntelliJ IDEA, and have a look at what we get. Yeah, I don't want the tip of the day. Okay, it'll take a little minute to import everything, but this is essentially a Micronaut application here. So one thing to note, which is pretty important when doing any comparison, and again, it's one of the reasons why I want to do this comparison personally, is that folks create applications with mn create app, as I've done, and they think that the application is exactly the same as like a Quarkus or a Spring Boot application. And in fact, it's not. You actually get a lot more out of the box with Micronaut than those other frameworks. So as an example, let's have a look at the POM file that gets generated. So as you can see, one of the dependencies there worth noting is that you get validation out of the box. So we on the Micronaut team don't believe any kind of real world application is ever going to be built without validation. There are a number of reasons for that, because one of them is because validation is required to validate your configuration. So when you configure your app through application.yaml or whatever, or through environment variables, you want that configuration to be validated, and if you remove this dependency, it won't be. So that's why we include it by default, and it's always there. It's not something you can remove it, of course, but we don't recommend it. Another thing we include by default is an HTTP client, which the other two do not, unless you count the really low-level REST template and web client that Spring Boot includes. But fundamentally, we include a fully featured HTTP client that includes like compile time, dependency inject, compile time, declarative clients, and so forth. So to make that comparison actually accurate, I'm going to move this dependency to the test scope. even though this dependency only really adds like 10 milliseconds of startup time. Just to compare apples for apples, we're going to do that. The other major difference between when you create a Micronaut application versus when you create a Quarkus application through their website or a Spring Boot application through their website is by default you get application.yaml. I know the YAML hate is out there, but fundamentally YAML is a very convenient format for configuration and is much loved by many users. So we do default to it. However, it does have a certain amount of overhead. Parsing the YAML is around 40 milliseconds of overhead, which you don't have to pay if you don't want to. So in order to compare apples with apples again, relating to the other two frameworks, I'm going to rename this to application.properties, and I'm going to turn it into a properties file, which is much more smaller and more efficient to parse than a YAML file is. So there we go. So now we have an application.properties. So now let's build a basic application that demonstrates some features. So let's, for example, create a message controller, and this is going to be my web controller that's going to respond to the root URI. I want to inject it with a message service, which I'm going to demonstrate, using a factory to create. So we're going to have a message service factory, which is going to be used to create my message service, and we're going to have a message service just to demonstrate exercising the DI system a little bit of each framework. So in Micronaut, the way you define like factory beans is essentially to do it with that factory, and then the methods can expose a bean. So this would be a message service bean, for example, which we want to implement. So to have some fun with this, we're going to make the message customizable via configuration. So to do that, we're going to pass in the message into the constructor, and what we're going to do is we're going to say that this maps to a property called hello.message, and the default value is hello. So what happens here is that when this object is created, Micronaut will look up this value from configuration properties, whether they be environment variables or the YAML files, application properties or system properties, and inject the appropriate value into there. And that value we can then pass to my message service, which is actually going to output my message. So let's do that. And this is my message service. So this.message equals message. And it's going to have a method, let's call it say hello to somebody, and it's going to do message plus space plus the name, like that. Okay, so I have a message service being produced by a message factory, and we're going to inject that into my controller using constructor injection. So let's do that. There we go, message controller injected. Now let's expose an endpoint that is going to receive the name like so, and it's going to produce, if I'm able to type properly, media type, text plain, and this is going to be my hello endpoint, and passing the name. And we're going to do message service.say hello to that name. There we go. And then what we're also going to do is we're going to say not blank to add a bit of validation logic to make sure that the name passed in can never be blank, to validate my endpoint and so forth, to demonstrate validation. Okay, so that's my application pretty much built. So how would I test this? Let's come in here. And let's write a message controller test. Here it is. And this is going to be a Micronaut test. And it's going to be injected with a client that's able to talk to the default server. And we have a little shortcut, which is / to do that. And we're going to get hold of the Rx HTTP client. and we're going to write test here, which is just a JUnit test. And we're going to say client.toBlocking.exchange, and we're going to pass hello John, and string.class is what we expect back. And that's going to give me a response, and then we're going to say assert equals HTTP status, okay, response.status, and probably we could place that with a static import, but we're not going to do that at the moment. And we're going to expect the message to be hello John, and that is what we expect the body response to be. So that's my test for my application. So how do I run this test? We run it, and we should get success, which we don't. We get a page not found. So why is that? Let's have a look. Oh, I guess I'm missing the hello part of the URI. You know, this should probably be hello. Let's try that again. Okay, so tests executed. And also important to note that the test executes in 374 milliseconds. Okay, so that's my basic Micronaut sample application built. So let's now do the same process and build the same application quickly with Quarkus. So let's go to code.quarkus.io, I think it is. Now let's create an equivalent application. So the equivalent application will include Hyphenate Validator and JAX-RS. So let's generate that. Generate my application. Save the zip. There we go. Now if we go into my terminal here, go into my terminal. Let's get the zip into an appropriate place. So move from downloads code with Quarkus here, and then unzip code with Quarkus. There it is. Move code with Quarkus to zip. Let's move code with Quarkus to Quarkus example, and open idea Quarkus example pom.xml. Okay, so new window. Okay, so let's wait for that import and see what happens and see what we get. So here's my Quarkus example. So let's see what we get. Again, we get a Maven project, and in fact Quarkus does generate me some example code already, which I guess is quite handy to get started with. So let's customize this. Let's rename this into a message resource, and to make it kind of equivalent to what we had before. Maybe it could have been structured differently, but we're going to do a template like that, and it's going to receive the name, and the name is going to be a path param, like so. And we want it to be not blank, validated. So that's equivalent. Now let's create my message service. And to save time a bit, we're going to take the Micronaut version and just stick it in here and copy and paste it. And let's create the message service factory, which again, to save time, we're just gonna copy and paste and customize so we don't have those things. This is going to be a singleton. It's going to, this is going to use config property instead of property, and what other differences do we have? So that's going to be a singleton. So I think that is pretty much it. Then we're going to inject the message service into my control resource, as they call it, and we say message service, say hello name. Okay, so we had a test already generated, so let's rename that. Message resource test for my test. And in theory, yeah, we have to change that hello John, and we expect the response to be hello John. Let's have a look at that. So this should work. Let's try. Run my tests, see what happens with Quarkus. Oh, build failure. What does that mean? Clear class, message source. Maybe message resource. Oh, I think I know what I've done. This should be a missing produces. That's what it is. So that has to be a produces. Okay, there we go. So in theory, we should be all set to go. And we are, so the test passes. Note that the test execution took 3 times longer than a Micronaut, but anyway, we'll leave that for further benchmarking. So we have our basic Quarkus application set up, which demonstrates a few features of Quarkus. And it's using REST assured for the test and that Quarkus test. So now let's go through the same process with Spring. So Spring, like Quarkus, we got start.spring.io. We're going to use the latest version, which is 2.3.1. We're going to do JDK 14. We're going to want equivalence. We're going to want validation and web flux. Reactive web, or whatever it's called. Okay, so those are the things that we want. We're going to generate the application and we are going to save it. So now let's go back to my comparison app and move from my downloads, the demo app zip, and we're going to stick it here, and then we're going to unzip it, and we are going to move demo to Spring example. There we go. And then we're going to open that Spring example in IDEA, same as the other two. New window. Okay, here we have my Spring application. So like with Micronaut, you get an application class. So that's one important difference that to note actually, is that both Micronaut and Spring has an application class that lets you run the app in your IDE. We'll get to that in testing IDE startup times in a minute, but it's an important difference. So let's go ahead and do the Spring implementation. So we're going to have a message controller, we're going to have a message service, and we're going to have a message service factory. And once again, it's probably easier to just copy the equivalent Micronaut code and adapt. So this is going to be instead an app configuration. This is going to be a value, and I think that you have to do some spell or expression language thing type arrangement. The default value, something like that. Oh, I'm missing an extra bracket. That should do it. Oh, no, what have I done? I've broken something. There we go. Okay, so that's my message, and this is going to be a Spring Bean. And then my message service is going to be the same. There we go. Oh, no, not that one. This guy. Message service is the same. And then the controller, we're going to copy and paste as well. And adapt. So we don't have Micronaut, so this is going to be a @REST controller that has a request mapping of root. And this is going to be a get mapping that produces text plain value, and we have validation, So one difference with Spring is that it will not automatically pick up the fact that this is not blank. So you actually have to explicitly say that this is validated. So for the validation part to kick in. Okay, so let's now run a test, and we have a test here already produced. Let's just rename it to something useful, and it's a Spring Boot test, and we're going to test the message. Now, I'm sure there's a whole bunch of different ways to test Spring apps, but for time purposes, we're going to replicate the rest assured way of testing. We're going to copy the dependency for rest assured, which Spring also supports, and we are going to stick in order to have an integration test loaded, we actually have to do web environment. Otherwise, by default, Spring produces some mock thing. So we don't want a mock thing, we want the real thing. And we want the local server port to be injected. And then we need a before each setup. We want to set rest assured dot port equals port. And then from the Quarkus implementation, it should just be the same. So that it should be identical in behavior. So let's run that and see what we get. So there's a little bit more overhead to setting up the tests with what has failed, something has failed. However, name must not be blank. Let's see, what have I done? Oh, yes, in Spring you have to have path variable name, unlike Micronaut, which just matches them from the parameter names. So a little bit more overhead to get it operational. And there we go. So Spring application up and running. So now we have 3 equivalent applications. So now let's look at different metrics. So first of all, one of the first metrics I want to look at is compilation time. So let's take the 3 applications which we have in here. So we have a Micronaut sample, a Spring sample, and a Quarkus sample. And let's run maven clean compile for Micronaut and see how long this takes. So total time 1.5 seconds for one run, 1.49 for the second one, 1.475, so 1.5 and below average more or less compilation times for this application that we can expect. Let's do the same thing with Quarkus. Clean compile, see what compilation times we get. Okay, so similar, 1.43, 1.425, 1.430. So that's a little bit faster than Micronaut, but not by a huge deal. Now let's look at Spring. Compilation times 1.35. So I expected Spring to win because it's the only framework that doesn't do any compilation time enhancement or processing. So when choosing one of these frameworks, remember that both Micronaut and Quarkus are compilation time based, so that's one factor that you need to take into account. Spring is marginally ahead when it comes to compilation time. So let's do another test, which is to test speed of test execution. So just a reminder, we are using JDK 14 for all examples. So let's go back to Micronaut and see how fast tests execute. So we're going to do a clean test run for each time and see what happens. Okay, so the first test run we looked at is 4.2 seconds. Let's run it again. 4.19. And the final one is 4.17. So you're looking at just under 4.2 seconds to run your test suite for this application. Now let's look at the equivalent in Quarkus and see what happens. Okay, so the Quarkus one took 5.8 seconds to run your tests. 5.8 on the first run. Let's try it again. 5.78 on the second run. And let's do one more time. 5.8 seconds on the third run. So we're looking at about 5.8 seconds versus 4.3 for Micronaut. So Quarkus actually takes quite a bit longer to actually run your tests. Something that you may want to factor in. I think that was pretty much obvious maybe during the demo, where when I run my Micronaut test inside my IDE, you'll see that the actual execution time is 394 milliseconds versus, for example, Quarkus, when I did the same thing, it was over a second. Let's run it again and see it was just a slow run. No, it's consistently over a second to run your tests. I guess it's just doing more, and this is probably based on the fact that Quarkus has this class loader setup, custom class loader setup. It's much more complex to set up, whilst Micronaut is just using the system class loader. So that's an interesting metric. Now let's do the same thing for Spring and see what we get. Spring clean test. And it's running my tests, taking its time, 7.5 seconds. So wow, that's almost double what Micronaut takes to run your tests. So that's quite a long time. 7.3 on the second run, and let's have a look. 7.3 on the third run. So I run about an average of 7.3 to run your tests. Okay, so that's the first metric we're looking at. So Micronaut is winning on that metric. Now let's look at a different metric. Let's look at development time, startup speed. So this is how long it's going to take to get your application up and running from running application. In Micronaut, you can do maven wmn run. And what do we get when we run that? So 4.65 milliseconds for the first run, as reported by Micronaut in its console, granted. So 4.33 in the next run. And let's run it again, 4.35 in the next run. Interesting metrics. So let's do the same thing with Quarkus to understand how long we're going to be waiting for your development server to start up. Okay, so first of all, what's interesting out the gate is that Quarkus is disabling the verifier. I found that very, very, very interesting, considering this flag is deprecated in JDK 13. And also that Quarkus is largely based on bytecode manipulation and then bytecode transformation. So it seems quite high risk that they're disabling the verifier to gain some seconds of development time, startup time. That's quite remarkable. Anyway, you can see that the development server starts in 0.89 seconds in the first run. Run it again, 0.893. It's probably also impacting the fact that they're starting the development server in debug mode, which is interesting as well. I guess the reason they do that is because unlike Micronaut and Spring Boot, there is no application class. So like, for example, for Micronaut, or for both Micronaut and Spring, you can come into your IDE and you can run the application directly from the IDE, as you can see. Interestingly, from the IDE, when I run the Spring, it disables the verifier as well to gain some startup time, which is, again, deprecated and should not be done. Micronaut, on the other hand, as well, also has an application class, so you can run from the IDE just the same, and debug. So if I wanted to debug my app, I would just go to debug. Whilst with Quarkus, you have to attach a remote debugger, and there's a bit more overhead and so forth. So going back to those results, then you can see that Quarkus is averaging around 0.89 something to start up the development server. Let's do the same thing for Spring. So Maven W Spring boot run. And see what happens. So it starts up, and we get the startup happening in 1 second in the first run, 1.09 to be precise. Let's do it again. So this time it's a bit faster, 0.95 seconds. And let's do it one more time. 0.95 seconds. So Micronaut the winner in that round once again. If development time startup is you care about, then Micronaut is the fastest. However, development time startup has its caveats in that each of these frameworks often uses special flags to improve startup time and so forth. So I think a better metric to all of this is to show java.jar performance. So let's do Micronaut clean package and create a jar file for Micronaut. And let's do java.jar target Micronaut example. So this is no special JVM flags. This is just pure Java to run my app. Nothing else. So that's right. And we get 510 milliseconds for Java in the first run, 507 for the second run, 507 for the third run. So more or less, that's what you can expect with Micronaut. So let's do the same thing with Quarkus. Let's do Maven clean package, and we build our jar file. And we do java/jar target Quarkus run code with Quarkus is the name of the project runner, and we run it. Okay, so with Quarkus we're getting 0.689 seconds startup time. Run it again, 0.684 seconds for the second run, 0.675 seconds for the third run with just java.jar. So let's try now Spring and do the same thing. Building the Spring jar, there we go. Now we do java.jar target demo and see what happens. Okay, so the first one we are getting 1.273 seconds to start up. Second run, let's try it again. 1.278. And again 1.281. Okay, so quite a bit slower for Spring, and Micronaut once again in the lead of the three frameworks. However, startup time as reported, every one of these frameworks has a fair amount of laziness in them, and also a fair amount of cost into setting up their respective Netty pipelines. Since each one is based on Netty, the cost of the pipeline setup can be a factor. And so what we want to do is we want to conduct another test, which is to test what is time to first response. Basically, that is the time that it takes for the application to start up and respond to the first request that comes in. This is a metric that's important for things like serverless applications or deploying to Cloud Run or Lambda or that kind of thing. And we have a node script here that is going to measure the time to first request. And what we're going to do is we're going to do Micronaut first. So we're going to say Micronaut time, Micronaut example target, and see how long it takes Micronaut to respond to the first request. So let's see, that first run wasn't the greatest. 978, 978, 978, 960, 959, 950. So you can see on average we're probably looking around 970, something like that time to first request statistics for Micronaut, which is pretty good in terms of Java. So now let's do the same thing with Quarkus. So let's do target Quarkus, code with Quarkus runner. And you can see that this is one area where Quarkus is ever so slightly, marginally ahead of Micronaut, at least in the 2.0 M2 release of Micronaut. But it's ahead in the kind of low millisecond range, so about essentially 60 milliseconds of difference. So, if those 60 milliseconds of difference are the deciding factor in your decision making, then Quarkus may be the framework for you, but there's a whole bunch of other things that you have to consider, and really it's not really a dramatic amount of difference to really make it a decisive factor. We're continuously working on performance improvements, and I think that we will be in a place where we're closer to match that. But, we're talking about 60 milliseconds of difference, which is not a huge deal. So in that metric, Quarkus comes out the winner, marginally. Now let's look at Spring. Okay. Time. Okay, so Spring's time to first request is, well, there's no other way to say it, pretty much double Micronaut and Quarkus by a good distance. So if you're choosing Spring and you're thinking of going to Cloud Run or serverless, just do factor this in, because it's, even with all the performance optimizations they've done and everything they've done, it's still a lot slower than Micronaut or Quarkus. Okay, so that's the time to first request. Now let's conduct another test, which is going to be a load test. So to see the difference in performance in terms of requests per second. So the first application I'm going to run is, and I'm going to provide XMX 128, which is the typical production setting that you would do for most kind of microservice apps in Java, and just so that memory churn doesn't become, and GC pauses don't become a massive issue. So let's run Micronaut first. There it is. Now we're going to do AB. Make that bigger. So AB, and we're going to use keep alive requests, because we're living in the world of HTTP, well beyond HTTP 1.0 in HTTP 2 world. So let's do ABK, and then do a concurrency of 20, and then do a number of, say, like 10,000 requests. Localhost 8080, hello John. So first run we get 14,000 requests per second, now we're getting 38,000 requests per second, 52,000 requests per second, 56,000. I normally like to do like about 10 of these runs before, because the JVM goes optimizing things and improving things, and as you can see, we're now in the 80,000 requests per second, 80,990, 77,000 that run, 80,000, 80,000. Okay, so 80,000, 81,000, 80,000, 79, 82. So around about, we can probably say around about 80,000 requests per second. Let's do the same test with Quarkus. So instead of Micronaut, we're going to do Quarkus. Runner starts up. Okay, so boom, 14,000, 34,000, 43,000, 51,000, 54, 52, 59, I expect it to go up, 76, 73, 76, 70,000, 80,000, so 79, 71, 79, 81, 73, 78,000, 70,000. Okay, so between 70 and 80,000, there's been a few runs where it's done 80,000, but overall you can see that request per second wise, there is not a huge deal of difference between the two frameworks. They're both approaching 80,000 or around about 80,000, sometimes 71 requests per second. So it's not a decisive metric that you maybe want to decide between Micronaut and Quarkus. Pretty much the same. So let's try Spring now. Let me go to the Spring example. Target. Demo. Okay. So let's run this. Now, what surprised me about when I was testing Spring is that it does not appear to support at all with Webflux Keep Alive. So I decided to exclude it from this particular comparison because if you don't support Keep Alive in your web stack, then I can't do an equivalent comparison because essentially it's going to be reconnecting for each request, which is not going to give me accurate results. So maybe somebody from the Spring community can leave a message in the comments about why this is the case, but essentially Keep Alive is not working for Spring. So that metric I'm going to leave out. So let's look at another metric then, which is memory consumption. So once again, we are going to run the Micronaut example. Here we go, I'm going to run it. And I'm going to put some load on it a few times. I'm going to play some load because there's no point in measuring memory consumption when the application has just started. JVM needs to optimize things, and that's going to eat up some space and needs to essentially get things going. So I'm going to run this a few times. And now I'm going to run Java mem, which is a little alias I set up to before. Actually, I can't even see what I'm doing next. I'm going to kill all and repeat that whole exercise. Sorry about that. We're going to repeat it again. Okay. So run those tests. Benchmark it. Run it, warm it up. Keep warming it up until we get to around about what it was before. And Java mem. So Micronaut's memory consumption, this is the RSS memory, as you can see, is in the 290 megabyte range. When you've hit your server with a bit of load and it's optimized everything and so forth. When you set XMX 128 megabyte, as you typically do in a production app. And so that's a good number. Now let's try the same thing with Quarkus, which have been making outrageous claims about their supposed memory performance versus other frameworks. Let's do the same thing. Let's place some load on it. Load until we get like to the 80,000 requests per second. There we go. So now it's probably warmed up. Now let's run the same. Okay, so after running that, Quarkus is consuming an additional 100 megabyte of memory in comparison to Micronaut at 390 odd megabyte of memory. Wow. Okay. So that memory claim is obviously not accurate. Let's do the same thing with Spring and see what happens. So again, we're gonna apply a bit of load, but I can't apply much load because it doesn't support keep alive requests. And let's see my memory stats for Spring after doing that. So Spring is doing 480 megabyte of memory. So let's repeat that. 290 megabyte for Micronaut, 390 odd megabyte for Quarkus, 480 megabyte for Spring. So if you looking for memory savings, you know which framework to choose. Now let's do the same test, but instead of 128 megabyte, we are going to limit the memory to 18 megabyte. And let's place load and do the same test. Repeat. So we're putting load on my service. So even though I've limited the memory here to just 18 megabyte of heap, you can see that the request per second metric has not gone. I mean, I'm still able to do 45 to 50,000 requests per second, 55,000 that time, 54,000, 56,000, 57,000, etc. So, and let's look at the memory after that. So with that limit in place, we have memory consumption of 249 megabytes after placing load on the Micronaut service. There it is, that number in the corner there is the RSS memory. And let's do the same process again for Quarkus and see how it performs in low memory consumption environments. So once again, we're going to place load. So similarly to Micronaut, it doesn't reach the heights of requests per second, but it's still able to sustain around 50,000 requests per second. It depends on the run, but essentially on average, maybe 45, maybe 40. And now let's look at the memory after applying that load. So 340 megabyte of memory. So again, that memory doesn't really change. It's extra memory that you have to use to run Quarkus compared to Micronaut. So I don't know enough about Quarkus's architecture to explain the difference in things, but one thing we can, if we do an analysis, for example, of Quarkus and this controller implementation, which has validated, if I put a breakpoint on here and run my test to see what kind of things are going on in here, you'll see that it's essentially some kind of AOP interception implementation, which all frameworks will be using. So this is the stack, but you can see that there's a fair amount of reflection going on in here. So we got java.lang.reflect.methods. In the actual invocation part, abstract method invocation acceptor, you can see that it has references to the java.lang.method for there it is, see the method down there, for my message resource. So it's using reflection to apply AOP. So this is one of the things that we were really strong on when we started designing Micronaut, was that we would not use reflection anywhere. And you can see that Quarkus is still using reflection quite heavily. And if we do the same analysis where we look at the stack for Micronaut, you'll see, so if I put a breakpoint on my controller and we run my test, or debug my test, you'll see that the stack trace is much smaller for one between the point where it's invoking, so it's only these 8 frames, I think, before it invokes your method, and absolutely no reflection is used anywhere in the invocation of your method. So why is not using reflection important for memory consumption? And the reason it's important is because as a framework developer, if you allow reflection, you essentially have no control over your framework consumer's memory consumption. Because if this controller had 100 methods, I would get 100 java.lang.reflect methods cached somewhere, which is immensely undesirable. So that's one of the reasons in Micronaut we really decided to not at all support reflection, or only support reflection as an absolute last resort, especially in our AOP layer and so forth. So that is my theory in terms of why there's such a big difference in memory. If Quarkus is still using reflection, then yeah, it's going to consume a lot more memory. So that is a comparison of the 3 frameworks and the kind of memory consumption and stats that you're going to be looking at. I did not do a memory consumption test with Spring using XMX 18 because it just ran out of memory, and it wasn't without the support for being able to properly do an equivalent comparison on load due to lack of keep alive. I just omitted that, but essentially the stats that I accumulated, and I've done this all live, is essentially here are the metrics in with the winner in red of on Open JDK 14 tested locally. Test time, Micronaut is ahead. Startup development time, Micronaut is ahead. Start time for running the jar with just java.jar, Micronaut is ahead. The one metric where Quarkus is currently marginally ahead by 70 milliseconds is time to first request, and as we get closer to 2A GA, I expect that we will be able to close that gap so that it's irrelevant, although I think still that 70 milliseconds is pretty irrelevant anyway. Then in request per second, Micronaut came out on top. Request per second with XMS 18 megabyte for a memory constrained environment, Micronaut came on top. I have omitted the Spring metrics, which I've done live because of the lack of keep alive connection support. Memory consumption after a load test was significantly better with Micronaut in all scenarios. So they're really if we look at 2020 comparison between these 3 frameworks, the only metric that Quarkus is currently winning on is this one, and the only metric that Spring is going to be winning on is compile speed in terms of performance. So I hope you enjoyed this video. I think that my aim with this video was to make sure that there is some updated information about current state of affairs in 2020. These frameworks are evolving and moving fast, and I'm sure this competitive space will continue to be so. But there is a lot of misinformation about differences between these three, or outdated information which uses older versions of the frameworks. So this will hopefully provide an update on the latest state of affairs. So thanks for listening.